Good morning and welcome. Thank you for joining us for today's webinar, Getting Lost in Semantics, Selecting the Right Search Engine. This is Steve Mann, Vice President of Sales at Concept Searching and one of your co-hosts for today's webinar. Just a bit about myself. I've been in the managed metadata space for several years now and currently spend most of my time focusing on business development and account management. Joining me is Robert Piddocke, Vice President of Business and Channel Development at Concept Searching. Robert, please go ahead and tell the folks a bit about yourself.
Thanks, Steve. So I've been in information retrieval since about 2000, and specifically working with Microsoft Technologies and SharePoint since around 2005. I have authored 2 books on SharePoint search, and I'm looking forward to showing you what Concept Searching to Do can help you with search.
All right, thanks so much, Robert. All right, first, some housekeeping items. We will be recording this webinar and we'll send all registrants a link to the recording and a link to the presentation. If you have questions during the webinar, please type them into the chat box and we will follow up with a response within the next few days. So our agenda for today, pretty straightforward. As always, we'll lead off a bit about who we are and what we do, then move into the crux of the webinar content around search, talking about search engines, search components. Then I'll turn things over to Robert, who will run through a live demonstration, and then a quick wrap up at the end. For those of you that perhaps do not know who we are, we've been around for some 16 years. We are focused on metadata generation, auto classification, and taxonomy management, with many of the world's largest corporations deploying our platform. Our platform is, or rather our software, is platform agnostic. And while much of the content of this webinar series uses SharePoint as the main focus, we are by no means a SharePoint-only platform. We are also the only solution in the market with a fully integrated, statistical, multi-term auto classification platform, which we use to deliver metadata-driven search and governance solutions. If you were to ask someone to describe their ideal enterprise search engine, they would likely say it would be quick, relevant, and offering some feeling of control, that the results match the intent and related content is identified even when words are not entered in the search string. As long as we're talking perfect, some would add that perfect enterprise search has to take advantage of how different people with different skill sets will use a given search engine, and to support the usage pattern based on different search patterns or tendencies. Search has a lot to live up to. It has some high standards in terms of accessibility and usability, both from a desktop computer and a more mobile scenario. So let's talk about some different elements that more and more comprise the quest for perfect enterprise search. In pattern recognition and information retrieval, precision is the fraction of relevant instances among the retrieved instances, while recall is the fraction of relevant instances that have been retrieved over the total amount of relevant instances. I know those sounded very similar. Both precision and recall are based on an understanding and measure of relevance. These are more important in data discovery and classification than search, but with regard to search, precision is how useful the search results are, and recall is how complete the results are. In simple terms, and what the graph attempts to show, high precision means that an algorithm returns substantially more relevant results than irrelevant ones, while high recall means that an algorithm returned most of the relevant results. So cognitive models of information retrieval. This is a concept that really falls more in the category of not quite ready for prime time. Some experts contend cognitive models of information may help in information retrieval with natural language searching. For instance, there may be a time in the future where rather than searching for local movies, reading the reviews, then searching for local Italian restaurants and reading their reviews, you will simply type, "I want to see a funny movie and then eat at a good Italian restaurant. What are my options?" into your browser, and you will receive a useful and relevant response. Although such a thing is not possible today, it represents a holy grail for researchers into cognitive models of information retrieval. The goal is to somehow program information retrieval programs to respond to natural language searches. This would require a fuller understanding of how people structure queries. So I'd say if anyone tries to pitch a product based on this promise at this point, I think I'd say buyer beware. Findability is the ease with which information contained on a website can be found, both from outside the website and by users already on the website. Most any organization will acknowledge the need to focus on reducing the effort for finding that a user would have to do for themselves. That is improving findability in a nutshell. According to Gartner, users will make 2 attempts at search in a given session, and if they're not able to locate what they want, they assume it does not exist or that they lack the proper permission credentials. If people are unable to find something, it goes without saying that that same information cannot be shared or reused. The core of the problem is that 50% of content is incorrectly indexed or tagged and thus unsearchable. So how do users search? So let's review some of the more common types of searches, starting with transactional search queries. These are search requests that indicate a clear intention to buy or concern a planned purchase. Those are regarded as transactional queries. Here, searchers are looking to acquire a product, either free or in return for payment, and they will use the search engine to select this product and visit the relevant website to make their purchase. Like all searches, transactional search queries have their own specific patterns and formats. These include not only verbs such as buy, order, or download, but also specific products and product brand names. Furthermore, though it may not be made explicit, there are some searches that imply a transactional intent. For example, a search for details of flights from Frankfurt to New York suggests that a searcher may actually want to book a flight. So the search engine will also offer suggestions on pricing and flight times. Navigation-oriented searches are targeting a certain kind of website. The user is not seeking a particular product or company and has no clear intent to purchase. He simply wishes to visit a particular type of website and uses the search engine to navigate there. Navigational searches are also conducted when the user does not know the exact web address or the correct spelling of the brand name or company he or she is looking for. Examples of navigation-driven keywords would include not only terms such as Apple and Frankfurt City Library, but also Nike running shoes. With such searches, users are usually trying to reach the websites or targeted subpages of brands, businesses, and organizations. Information-oriented searches are probably the earliest form query because search engines were first developed to filter specific information from a data set that has become unmanageably large, the World Wide Web. Due to this, users employ informational searches whenever they need guidance, background information, or specific information about a topic or product without having any concrete intention to purchase or any wish to seek out a certain landing page. Information-oriented searches can utilize an infinite variety of different keyword combinations. They can be presented not only in question form, for example, how do I make coffee, but also as simple word combinations like making coffee. Even a single word such as dog can be interpreted as an information-driven request. Search engines will then provide general information about this keyword, often available on informational sites such as Wikipedia. Search engines like Google present different kinds of content based on assumptions they make about the underlying intentions of a user's query, and results for transactional, informational, and navigational queries can therefore look quite different. While the search results for transactional keywords generally call up the appropriate online store, results for navigational searches usually include the actual brand or company pages. For those seeking information, Google often displays blog articles, tutorials, and videos, as well as knowledge bases such as Wikipedia or Merriam-Webster. All right, someone searching for information will generally fall into one of four categories. First is the double expert. The user possesses both the subject matter knowledge and digital expertise to find what they need. Next would be the digitally savvy user. This user is a digital expert but has difficulty expressing what they want to know. So their lack of knowledge in the subject matter affects their ability to determine the amount of information necessary to find it. The double novice. As the term implies, this user does not know what they need to know and thus may waste time exploring information sources without having a definitive objective. And finally, the subject expert. This person wishes to find information it has prior knowledge of, i.e. they know it exists. However, they do not know where to find the content. Effective search has to consider the double novice's needs and lack of expertise, but also offer the efficiency double experts expect. Examples of characteristics that distinguish subject matter experts and novices is what words they use when searching. The expert believes they know what something is called and may have difficulty using layman's terms. This behavior requires that the terminology is supporting both the expert and the layman's way of expressing themselves. Examples of different digital maturity. The expert can take advantage of advanced tricks learned from other technical environments. For example, to use complex search queries or actively control acceptable misspelling. The novice's needs, rather, are met with an introductory, an educational way, so as not to be caught off guard by too many possibilities at once. Ideally, contextual tips are provided when they are meaningful and the benefits obvious. Google's addition of know, simple, and that's K-N-O-W, indicates that Google understands that the do, know, go categories are no longer broad enough for the modern search landscape. However, I believe that even with the addition of know simple, the model could be improved upon. SEOs have traditionally used the navigational, informational, transactional framework to classify the searcher's intent. We believe that a large part of this can be captured by considering how user intents may change and be better served when they've been conducted via an intelligent personal assistant app. The last couple of years have seen an explosion in the functionality and usage of an increasing number of personal assistants. Apple Siri, Google Now, Microsoft Cortana. All right, so the difference between web search and enterprise search. A web search engine is a software system that is designed to search for information on the World Wide Web. The search results are generally presented in a line of results, often referred to as search engine results pages. The information may be a mix of web pages, images, and other types of files. Some search engines also mine data available in databases or open directories. Unlike web directories, which are maintained only by human editors, search engines also maintain real-time information by running an algorithm on a web crawler. Enterprise search is the practice of making content from multiple enterprise-type sources, such as database and intranets, searchable to a defined audience. Enterprise search is used to define the software of search information within an enterprise. Though the search function and its results may still be public. Enterprise search can be contrasted with web search, which applies search technology to documents on the open web, and desktop search, which applies search technology to the content on a single computer. Enterprise search systems index data and documents from a variety of sources, such as file systems, email, and databases. Many enterprise search systems integrate structured and unstructured data in their collections. Enterprise search systems also use access controls to enforce a security policy on their users. And enterprise search can be seen as a type of vertical search of an enterprise. All right, if you joined this webinar, you probably are not satisfied with your organization's search. Search isn't easy. especially if the user is not only challenged by a lack of tools to aid in search, but also expected to find something when receiving feeds and notifications if anything of importance occurs. The information itself needs to become more intelligent. The business goal for search is primarily to avoid the risk of someone acting on outdated knowledge. Secondarily, to offer a complete picture to the information, not to unnecessarily develop or purchase information or things that already exist somewhere within the organization. We should strive to make the benefits of search known and the platform well used to realize these goals. Which brings us to intelligent search with machine learning. So the ultimate goal is to get the right information when it is needed. Get means that the information reaches the user automatically through feeds, notifications, or through manual search. With the right information, quote unquote, the accuracy, validity, and relevancy is implied. By quote unquote, when it is needed, we pinpoint that the information reaches the user in the context the user is currently at and with the tools that are available, PC, mobile, etc. A good example of this type of search is intelligent medical search, which incorporates many of the elements listed on this slide. Often users are uncertain about their exact medical situations, are unfamiliar with medical terminology, and hence have difficulty in coming up with the right search keywords. An intelligent medical search engine uses several techniques to improve its usability and search results query. First, it uses an interactive questionnaire-based query interface to guide users to provide the most important information about their situations. Users perform search by selecting symptoms and answering questions rather than by typing keyword queries. Second, it uses medical knowledge to automatically form multiple queries from a user's answers to the questions. These queries are used to perform search simultaneously. Third, it provides various kinds of help functions. For instance, if a user has made incorrect selections, does not know which symptoms to select, or cannot answer a question, he or she can invoke the search engine's help functionality and describe his or her health situation there. Then he or she will see multiple lists of help information, such as one list for relevance of unselected symptoms and another list for relevance of alternate responses to the selections. The contents of those lists are ranked using medical knowledge and specially designed medical information retrieval techniques. All right, natural language processing is the branch of artificial intelligence that deals with generating, understanding, and analyzing the languages that humans naturally use in order to communicate with computers using natural human languages instead of computer languages. Recent approaches to NLP are based on machine learning, where data is fed into the learning machine with every action and non-action feeds, and then the task gets automated without constantly requiring human or manual interference. NLP has some tasks involved like named entity extraction, deep analytics, and sentence segmentation. It sits at the intersection of artificial intelligence, computational linguistics, and computer science. For any search using natural language processing, the program will recognize any abbreviated terms or acronyms. The challenge lies where computers have to understand the way humans use and learn the language. Human language is not simple, nor is it precise. For computers to understand human language, they need to understand the concepts and their linkage with the words to create a meaningful sentence. By employing NLP, developers can organize knowledge to perform tasks such as translation, relationship extraction, and sentiment analysis. NLP algorithms are mainly derived from machine learning algorithms, and NLP can rely on machine learning instead of hand coding large sets of rules to automatically learn these rules by examining a set of data. NLP is used to study text to comprehend how humans interact. This computer-human interaction enables real-world applications like part-of-speech tagging, topic extraction, and named entity recognition. NLP has its uses mainly in machine translation, text mining, and automated question answering. NLP can be leveraged by companies to improve the accuracy of documentation, the efficiency of documentation processes, and to recognize the most relevant information from large databases. Our searches provide clues about your interests. In search, those clues are known as signals. When processed by machine learning and integrated with search, they are used to automatically influence the relevance and results you'll see. This is a far cry from early enterprise search like Verity, Fulcrum, and others. The problem is even ML and advanced technologies are not quote-unquote fire and forget tools. They still need to be set up properly. They provide the ability to train an instance with search, which can then be used and extended over time to essentially incorporate user behavior, which then becomes even more signals. Machine learning basically generates a profile for both users and for content. This enables search to display results that quote-unquote people like you have found helpful. Note that the profile uses many signals, but generally the signals are behavior-based and do not incorporate personally identified information. For example, your work profile, job title, documents you've authored or viewed, sites and content you view, provides the signals that, in addition to the query you enter, are used at search time to produce results. Think employees like you. Machine learning isn't destined to fail, nor is it a panacea for fixing enterprise search. Enter any new search project with the objective to improve search, not to make search like Google. Plan on staff and time to train machine learning appropriately. Verify it's well integrated with their search platform. And remember that even artificial intelligence-driven search is not magic. It takes time to set up and manage. But without that training and management, you're going to be unhappy with machine learning-driven search. Artificial intelligence is intelligence demonstrated by machines, in contrast to the natural intelligence displayed by humans. Colloquially, the term artificial intelligence is applied when a machine mimics cognitive functions that humans associate with other human minds, such as learning and problem solving. The field was founded on the claim that human intelligence can be so precisely described that a machine can be made to simulate it. AI often revolves around the use of algorithms. Many AI algorithms are capable of learning from data, working on the basis that strategies, algorithms, and inferences that worked well in the past are likely to continue working well in the future. Artificial intelligence applications have been used in a wide range of fields, including medical diagnosis, stock trading, robot control, law, scientific discovery, and toys. The overall goal of artificial intelligence is to create technology that allows computers and machines to function in an intelligent manner. The general problem of simulating or creating intelligence relates to an inability to mimic human traits, such as reasoning, knowledge representation, perception. Many of the things people know take the form of working assumptions. For example, if a bird comes up in a conversation, people typically picture an animal that is fist-sized, sings, and flies. Now, none of these things are true about all birds. For so many items, there is a qualification problem, rather. For any common sense rule that AI researchers care to represent, there tend to be a huge number of exceptions. Almost nothing is simply true or false in the way that abstract logic requires. The number of atomic facts that the average person knows is very large. Research projects that attempt to build a complete knowledge base of common sense knowledge requires enormous amounts of laborious ontological engineering. They must be built by hand, one complicated concept at a time. Finally, much of what people know is not represented as facts or statements that they could express verbally. For example, a football coach might avoid running a certain play because it just didn't feel right. Or an art critic can take one look at a painting and realize that it's a forgery. These are non-conscious and sub-symbolic intuitions or tendencies in the human brain. Difficult, if not impossible, to develop an algorithm for such thinking. All right, so you're probably due for a break from the PowerPoint, so I'm going to turn things over to Robert, who's going to run through a demonstration for you of the concept searching solution.
Thank you, Steve. That was a lot of great information. So I am going to talk a little bit about what concept searching can do to help you with search. I'm not going to talk about all the things that Steve covered, because there's really a lot, and concept searching's products can help with things that he mentioned, like document interpretation, query analysis, entity extraction. But really, I just want to start with the basics and talk about precision and recall, which is one of the first things that Steve mentioned. In order for a search engine to work well, we need both proper recall and precision. And these are two areas where concept searching specializes in. First of all, we can help you get all of the information, so we can improve that recall, make sure that all of the results that are in your organization are retrieved in a document set in the search engine. In this demonstration, I'm using SharePoint Search, but we're really quite agnostic to the search engine you're using. So for example, in this test, let's say, for example, I work for a trucking company. I'm a truck driver, and I come to my company's SharePoint site because I want to find out about the driving test that I need to take. It's time for me to renew my driving test for this. I might come into the site and just search test. We're a trucking company. We should have all of that information in here. In order to get proper recall, I need to make sure that all of the different items that I'm getting are from everywhere in my organization. So if you're interested in connecting different systems like Yammer, please reach out to us, because we can help you improve that recall. The other thing we can do, and maybe more importantly, is we can also help with precision. And precision is, of course, getting back the best results at the top of the result set. You can see in this result set, I haven't found the test I'm looking for. I've got all sorts of other things about the company and the things we're doing, but I don't have my test. And that is because test is a very simple term. For me, it's the right term, because I'm just out there and I need a test. They told me I need to take the test. But really what I want is this driver's assessment information here that I want to go. So how do I get this back? How do I improve this so that my end users can go and find that, can search in test or driver's test and get back this information? Well, on the back end, concept searching provides an ability to create rules, if you will, that allow me to refine the kind of language that my end users are using and match that with the information that I have. So I know that I use assessments in my organization, but my end users don't use that. How am I going to get that result to the top? Well, for precision and recall, we want to make sure that the documents that we have the right terms. So I can make myself a classification for driver's tests. And this is probably something that's quite commonly searched for, so I can see that in my analytics or the reports that we provide, and make some clues. This is kind of a fuzzy logic. So I can ask the system to suggest some clues, tell me what is related to assessments, or I can add my own clues here and say, okay, I want to add any term or any document that has assessment in it. I also want it to be tagged as tests. And this can be done across the entire organization. Now, you're probably thinking, oh, I don't want to have to do this kind of thing for every single term. Luckily, every organization has its own jargon, and there are a few phrases that we can identify with compound term processing and by suggesting clues that will help us to find the right terms for your organization. And then we can automatically add them to here as a clue. Now, there are different kinds of clue types, and as I said, this is kind of a fuzzy matching, so we can say that it needs to have assessment on it a few times in order to be classified as that document. But then any document that has the word assessment will also be classified as tests. And this really helps to get that precision up, so we can then ensure that as users search for driver's test, they're going to get back the right document for assessment and all the other terms that are across our organization as well. This helps search, of course, with our precision and recall, but it also helps in ranking, which is another important thing for getting the right content back. Users, if they search for a specific item, they are expecting to get that item back in the top of the result set here. They're not expecting to have to do refiners. Of course, refiners are very useful, and having some good metadata to be able to do refiners is good. But really the best is just to have the document at the top. And if you have the right metadata on the document, using a system like ours to tag that metadata, you're going to get that best ranking, and it's going to help your search. Okay, back to you, Steve.
Okay, thanks, Robert. Great demonstration. Okay, so just to maybe summarize a few things that Robert showed, some must-haves in a search solution. Centralized metadata management that supports the user's language, whether it's layman terminology or not, to connect the expert's terminology with the novice. The metadata management should also provide support to other information systems or directly to the content creator to provide up-to-date feedback on how findable the information will be once it is published. Master data management, product information management, and reference data in order to identify the business's physical and digital items from the abundance of information available in search. And directories to find people, traverse the structure of the organization, and other commonly used directories, both internal and external. The approach yielding the best results is one that creates a managed metadata solution based in large part on a statistical analysis of an organization's own content, thus ensuring it is optimized for that environment and able to deliver the right information to knowledge workers as it is required. Numerous side-by-side comparisons over the past several years have shown this approach to be more intuitive, effective, and user-friendly than ontology-based academic tools. Concept Classifier platform automates the process of generating metadata and tagging content with that metadata, cleans up file share content, removing rot, and it improves search and can support other information governance projects. The Concept Classifier platform integrates and operates in Microsoft environments, including SharePoint on-premise and online, OneDrive for Business, and Exchange, and includes our compound term processing engine, which is a key differentiator that is still unique in the industry. The Concept Classifier platform reduces the cost of content ownership. It reduces risk with searchable, findable, and organized content, leverages automatic population of metadata to the managed metadata fields, saving time and human resources. It is highly scalable and a flexible approach to effectively manage content. And a unique concept identification enables the creation of organizationally defined taxonomies, reducing the taxonomy development time by 80% versus competing products. And tagging and auto-classification of content can be aligned to business goals, and semantic metadata generated integrates with any search engine or third-party application that can interface via web services. All right, that concludes today's webinar. Please join us for our next webinar, Why You Need Metadata-Driven Records Management. Full details can be found on our website. Thank you for joining us today, and as I mentioned at the start, we will be sending out a copy of the webinar and the slides in the next couple of days, along with responses to any questions that have been raised. If you have any further questions, please feel free to reach out to either of us or our marketing team, and everyone have a great week.